Hi, and welcome to this first video in our series on equations of motions from the mechanics section of the course. And what we're going to be doing in this series is firstly looking at the differences between scalar quantities and what is a vector quantity. Then we're going to move on, look at different types of graph that represent motion of a particle, displacement time, velocity time. Then onto the Suvat equations, which you may or may not have already seen in your studies in physics. And then finally looking at how we can apply these with objects moving under the influence of gravity. However, this first video is just a quick introduction where we're just going to take that first point, which is looking at the difference between scalar quantities, vector quantities, making sure that you've got a clear understanding of the difference between those and how that impacts on future calculations and future problem solving. So here we go. Key terms that we need to know before we start really studying particles that are moving. So we've got a vector quantity that's got two components. It's got a magnitude and a direction, whereas a scalar quantity only has magnitude. And by magnitude, we just mean size. So the difference, essentially between the two, is that the vector has a direction as well as the size. So if we just have a look at vector quantities and their equivalent scalar quantities, and the key terms that you're going to be dealing with, firstly, is on the vector side is something called displacement, which basically tells you where an object is relative to a particular point. So if we have a look at this number line here, and we've got O on the number line, there is the origin, and we would say that X has a displacement of 3 meters from the origin, so that distance there being 3, whereas Y has a displacement of -3. Note there the negative, saying Y is to the left of the origin, so its displacement from O is different to the displacement of X from O. So X is 3 meters, Y -3. If you have a look at the equivalent in scalar terms, and the term we're looking at there is distance, which basically just tells you how far an object has travelled. So again, on our diagram, we've got O, X and Y, and those two things are the same distance. They are both 3 meters from O, because, for example, to get from O to Y, you've travelled 3 meters. However, if we consider an object that started at O here, moved to X, and then went back to Y, we'd be saying that the total distance travelled would be 3 plus another 6, so that's 9 meters, so its distance travelled would be 9 meters, but then the displacement would only be -3, because displacement, remember, just measures how far it is from our initial starting position, so that would be -3, whereas that complete journey there, as indicated by my cursor, would be 9 meters. Okay, so that's the difference between those two things. So those are the first two, displacement and distance. The next one we've got is velocity, and velocity measures how fast an object is moving, and also it's got direction, so we've got positive velocities and negative velocities. So here's our little car, there it is. So we say, well, that motion there, you might say it's travelling with a velocity of 3 meters per second in the direction which is to the right. However, if we turn our car around and make it move that way, then we'd say, okay, that's got a velocity of -3 meters per second, again, because it's going in the opposite direction. Right, so let's just get rid of him. There he goes. The equivalent on the scalar side is speed, and that is just literally just how fast the object is moving without the direction, without the positive or the negative bit. So essentially speed is just the magnitude of velocity. And we'd say that average speed is distance travelled divided by the time taken. That's your kind of speed is distance divided by time that you will be very familiar with from earlier studies. And then finally, on the scalar side, sorry, not on the scalar side, try that one again. On the vector side, we've got acceleration, and that is the rate of change of velocity. We haven't got an equivalent of that one on the scalar side. Last thing just to mention in this video is just we've got a couple of assumptions when we're modelling motion. First of all is the fact that we're just going to deal to begin with motion in a straight line. That's either going to be horizontally or vertically when we start looking at problems due to gravity. The objects that we're talking about, whether it's a car or a person or whatever it is, we're just going to model it as a particle, which means we can ignore the size of it, which means we haven't got to worry about things like air resistance and drag and all that kind of stuff. So we're just going to trim the model down so we can just kind of concentrate on 5 basic quantities that we're going to be in our model. So we're going to take out the more complex bits to begin with. And finally, on this particular section, we're going to be working with situations where acceleration is a constant value. Later on in the course, we will deal with variable acceleration, but for this particular deal, And for this particular section with CVAT equations, all the rest of it, we are looking at constant acceleration.